Hello, my name is Carl Cook, and I'm Chief Technical Officer of IntelliDynamics, a division of Biocomp Systems. And in the prior video, I gave an introduction to the NGO and how to do modeling. In this case, I'm going to show you how to use it to actually do something useful. And this also applies to our Intellect Expert tool because the modeling window is very much the same. The differences being that in the NGO is more of a desktop tool and you can access files and bring in the data, where the Intellect Expert tool works with the Intellect server and can access many more different kinds of data sources, and also has data virtualization. That is to say, if I'm going to get data from SQL Server or from OSI SoftPy or from text files or from elsewhere, I don't care where the data is. Once you set it up, it just gets the data there forward, and you don't have to worry about logging in or anything. So the data virtualization aspect of it is one of the bigger things that are the difference, but the modeling window itself is very much the same. When I gave the introduction to the NGO and its modeling abilities, I just kind of walked through a process using a demo data file. And that demo data file is very useful. I'm going to use it again here to actually show you how you can use the NGO and expert to determine the cause of a problem. So I'm going to maximize the modeling window so you have a little more real estate. I'm going to double click on this data file and bring it in. And I'm going to go to the pre-processing tab and look at the output. And you may, if you saw the other video, you saw these divots in the data. In the other video, I said, oh, those are outliers. I'm going to throw them out. Let's pretend for a moment this is quality for your product, and 0 is good, and a negative number is bad. Well, all of a sudden now, maybe they're not outliers. Maybe they're actually indications of bad product, and you want to know why. So you don't want to throw out the outliers. You want to study the outliers. And that's one of the reasons that we advocate don't throw away, don't clean your data. Save it as it comes, because what one man is junk is another man's gold when it comes to analysis. And in fact, what was junk in one application may be gold to you when you're trying to figure out, why do I have these spikes? Now, I know how the data set was created, and I know why these spikes exist. It has to do with having a ratio of the log of a number in the equation to create this output. And when that number gets like way weird, then this goes way negative, and it doesn't happen very often when computing it. So I know that the input C is the culprit here. But in order to put this into a context for, let's say, manufacturing, let's say that input A is actually a process pressure. So I'm going to go click on the renamer, and for us, just for fun, I'm going to call that pressure, and double click this while that variable is selected. And then I'm going to rename this to say, oh, temperature. Temperature. B is selected, double click renamer, and renames it. And let's say that C is the percent material X. And double click that. And then output, let's say, is quality metric, and I'm going to rename that. So now we've put it into the context of manufacturing, where I've got a pressure and a temperature coming off the manufacturing line. I've got a materials thing that says this is how much material X they dumped into the tank and or used in the process, and then here's the quality metric coming back from the lab. So, of course, in real life you wouldn't need to do the renaming unless you wanted to. This is only for the purposes of this demonstration, just to put it into a context. But I'm not interested so much in the quality metric itself. I'm interested in whether or not there's a problem with the quality metric. So if I take a look at it, this is all negative numbers. And what I want to do is create something that goes from 0 to 1, where 1 is a problem. And then I'm going to model that and figure out what variables on the inputs affect or cause that to go to 1.0. So I'm going to multiply this. If I scroll up and find mult, I'm going to multiply this by -1. And so I set the property, quality metric selected, and I double click that, and now I've got a indication of badness, but it's not 0 to 1. So I want to go to this binary 0, 1 and say anything less than a threshold, set it to 0. So let's say the quality spec is 50. And so anything that's less than 50 will be set to 0. That's good. 0 is good. And anything above 50 will be set to 1. That's bad. So now I have a binary indicator of going from 0 to 1 of whether or not I have a problem. So now I want to do is find out which one of these variables is driving that problem, whispering that we know that percent material X is the culprit. Okay, but you don't know that in real life. So I'm going to go over here. I'm going to say these inputs, and that's an output, and I'm going to build models. And then it will go and try to build a model that says goodness or badness, and try to figure out what are the things that are causing bad indications. So it's done building models. I'll go over to the models list, and I see that my correlations are quite high. If I click on my system model, which is the average of these actual physical mathematical models, I can see that it does fairly well. It doesn't go all the way up to 1.0, but it grasps an indication of what's going on. And I look down here and it says 98% or 99% of the badness occurrence is due to percent material X. But we knew that already, didn't we? So that's a good thing. So that basically, if you didn't know that, then now it's telling you. It's saying, if you've got a quality problem and you're looking at your input variables, trying to figure out where it's coming from, it's saying, go look at how much of what percent of material X they're putting into the process. That's your cause. And that helps immensely in trying to diagnose the cause of a problem in manufacturing. So you can also go over here and you can generate reports, a Word document documenting all this. You can take a look at response curves and surfaces and those types of things that I indicated before. It also will show you that percent material X has got to get kind of a threshold, and then it takes off. So I hope that you found this useful, and please take a look at some of our other videos, and thank you very much for your time.